So hi everyone, I'm Anne Høyen. I'm a colleague of Kai's, and I am based in Denmark, where I'm at the moment. But I know exactly for those of you in the room where you are. I've been there a few times, and I hope you have a very nice day there together with the NRC and Kai and the others. And for those of you online, please do write some questions in the chat if there's anything you would like to ask as we go along the presentations today. So the next, so you just received a very high-level introduction to what SNOMED CT is and some of its features. Just wanting to let you know that we do have some e-learning courses as well. If you want to understand the foundation of SNOMED CT even better, we have a free online course that you can take. So if you're interested in that, please reach out to Kai, and he will show you how to access it. But this session is about SNOMED CT in the electronic health record. I'm going to speak a bit about the role of SNOMED CT in the electronic health record, about doing search and data entry, and query and analysis. And hopefully we have time so I can give you a bit of demonstrations. So as Kai was saying, SNOMED is the global clinical terminology, and it's designed to add meanings to electronic health record. So notice that it's not to add codes to a clinical record, it's to add meaning. And SNOMED CT is designed to contribute to high quality, consistent and safe healthcare delivery. So that's our overall objective, is really that we want to make sure that the data quality is high, that it's reusable, so that we can support the safe and efficient delivery of healthcare. And SNOMED CT is designed to be integrated in an electronic health record. And when it, as Kai was saying, it has a very broad scope. It has also a very high expressivity, because SNOMED CT is not designed to be the language police. So to state this is what you should say and how you should say it. No, it actually supports the requirements of the clinical domain. So what are the things that are important to capture? We don't define that, but our users define these are the concepts that are needed. So that's why we will include them. And some hierarchies will have very high specificity, so have very granular concepts, while other may not have as granular. It really depends on the clinical use cases. But to enable the benefits of SNOMED CT, it's not just to have a standard clinical terminology, it is to make sure that it's part of a well-designed system. SNOMED CT can be implemented poorly, and then it will then it won't have a lot of effect. But over to today's session, I hope that we can give you some insights to how you can actually utilize it so that it becomes a powerful resource that can add value to your systems. When clinicians use SNOMED CT, they do it often through an electronic health record. And the experience they have with using SNOMED CT will be dependent on how it's integrated and implemented. And overall, like architecture, you can say, of how you would use SNOMED CT in a health record. And I must say there are many ways, but this is like a recommended and best practice technique, is that you have the health record with the user interfaces and the data store where you store the clinical data. So in that data store, you'll find, well, this is the patient with this name and identifier. This is where the patient lives, but you also get these SNOMED CT relevant information, such as what is the diagnosis, what are the procedures and test results performed on this particular patient. And those codes for signs and symptoms diagnosis that are associated with the individual patients, they come from the terminology. So all the concepts, descriptions, and relationships that exist in SNOMED CT, and also subsets and maps, as you will hear later on, they could be part of what we call a terminology server. So that is not linked to the actual patient data. That's just like a server with all the information about the terminology resources or the code systems that you're using. And then your health record can access that information via standard APIs. So, for example, when a clinician search for a diagnosis in a field, the system will then ask the terminology server, what are the diagnoses that match my search string? And the terminology server will get back with these are the concepts from SNOMED that match the search string. And I'll show you an example of that. But this is just to show that here we separate the electronic health record from the terminology server. And the value of that is that you can have a terminology server that is set up so that multiple systems can use it effectively, so that every time there is a new update to SNOMED, new concepts or changes to SNOMED, this terminology server will be updated, and there isn't any configuration required on the electronic health record necessarily. So it will be very easy to make the changes reflecting the systems. So it really supports the easy updating and maintenance. You will let me know if there's any questions, right?
I will. I'm not aware of any
Thank
yet.
you. All right.
I'm waiting in
Thank you.
anticipation.
Good. Thank you. So with that type of setup, that shows like an overall architecture that can be applied. And this setup will support different electronic health record tasks that you may have in your system. SNOMED can support search and data entry, retrieval analysis, decision support. We also call it linkage to knowledge resources, so knowledge linkage. And it can also support communication and exchange. One of the key motivators or drivers in Europe at the moment is that there's a lot of interoperability work going on from the European Commission on how is it that we can start to exchange data, not even just in a single country, but also across country. And that requires standard terminologies such as SNOMED. And we'll also talk a bit more about that later. And then data storage, of course, where you can consistently store the identifiers and descriptions for the codes that you have documented in the health record. But let me now dive into search and data entry and how SNOMED CT supports that. So some of the requirements that end users may have when they document findings and procedures and information in general in an electronic health record is that the language they use and the terms that they use should be understandable to them and recognizable. The objective is to use the clinical spoken language. In the past, it has been very common just to write free text, but there's a lot of that can be quite challenging to then subsequently do analytics and data sharing if you have everything in free text. So starting to apply structured approaches, but still retaining the clinical language is very desirable. Another requirement is that some coding systems used in healthcare today have these codes where you can actually, from the way that the code is structured, you understand somewhat what this is about, if it's an infectious disease or if it's a cardiovascular procedure, the codes will have meaning. But for SNOMED, it's important to avoid the meaningless or display of meaningless codes. It should really be the clinical terms and the accurate representation of the meanings that should be the driver. Then, because SNOMED CT is so big, it's also important to talk to this requirement that you can't just have everything available and then pick and choose, because then it will soon become a mess and you will be very inconsistent. So when you design a system using SNOMED CT, it's important only to show relevant options to a user within a given situation. And that's what the session after this one about terminology binding is really very much about. And then it's also about end user preferences to data entry should be applied, meaning that the clinician should be able to use and capture information in the way they prefer. If they like check boxes or if they like drop-down lists and so forth, they should be able to specify those requirements so that the user interface will be intuitive and useful for them. So, as Kai was saying, SNOMED concepts can have many descriptions. So here I'm just looking at the concept heart disease with a unique identifier, and there will be many terms associated with that. So a clinical user can use the terms that they would like in their implementation. So if we look at these two systems over here, one of them may document heart disease, the other one may document cardiopathy. And that's fine because this clinician down here and the department he's part of may have, it's common for them to use this term, where up here, it may be a different profession, it may be a different domain, they prefer the use of heart disease. And the search feature will display these terms by the preference set in the implementation. But the point is that regardless of what term they use, it will point to the same concept identifier, meaning that it will add to the consistency that we know what concept we're referring to, even though it's different terms. And in order for a SNOMED CT description to be added, one feature is that it of course needs to be a synonym, a real true synonym. They need to relate to the same meaning. So we can't specify we can't make alterations in the meaning of these terms. They need to be very accurately synonyms. There are also implementations and a lot of development in process at these days around using some AI or natural language processing techniques to actually allow the clinician to document using clinical words, but then there will be an algorithm that can extract the clinical concepts that have been referred to, and then the clinician can go back and confirm whether or not these are the right ones. Yeah, and with the second requirement here about hiding and avoiding the meaningless codes, these are the key principles for implementing SNOMED CT, that you hide the identifiers, because as you may have noted, these identifiers is just a long list of codes. They don't provide any meaning to the clinical user. Yeah, and the other key principle is to use the terms that are familiar to the end users. Yeah, this is just an example to show, well, this doesn't make a lot of clinical sense, but actually just showing the terms does. And some people would then ask, but wouldn't it be a value to both show the term and the identifier? But the answer is really no. There's no reason to display the codes. The codes are intended for storage, so you should remember to store them. Because you will use the codes when it comes to data queries and data exchange. So here about the relevant options is the reason why this is a very important principle is both to reduce the time that's required to search and for the clinician to find the values. And then it's also to mitigate the risk of capturing unintended meanings. And as I'll show you later, there are really options in SNOMED where you could do that if you don't implement it correctly, where you may select a concept from a wrong hierarchy, even though that wasn't your intention. So it's really about understanding how to navigate in these hierarchies. And it's not the clinicians that needs to be able to navigate, it's the implementers who are setting up the systems to effectively use SNOMED CT. So for example, if you are in a user interface where you capture diagnoses, you You may use concepts from the clinical finding hierarchy, also for symptoms, but also for the results of an observation or a test. Other fields, procedures, tests, care and therapy, follow-ups may be documented by concepts in the procedure hierarchy. Social context, such as who are the relatives or next of kin of a patient, may be found in the social context hierarchy. So these hierarchies are really a foundation or a guiding line for where to look, depending on what is the type of information you want to represent. This is also what I said before. We don't dictate the visual design. We don't say this is how you have to capture a vital signs or something else, or a blood pressure measurement. But we do SNOMED CT with this strong computer processability, allow users to define this is how we want to select. And there, of course, we do have some recommendation. So if you have an input field where you can search across thousands of diagnoses, well, then it's a good idea to implement like a search field where you can just do a lexical search. We say that every time you have a data entry control, the thing that you can search across is the value set. And the set can either be defined by a rule, or you can define it manually. If you have a set of 50 concepts, maybe for rare diseases that you have defined, you may have selected those manually. But often it may be a benefit to have more general rules, because then you don't have to maintain the set, but you can maintain the rule. And this is also something we'll talk a lot more about later, also when Alejandro joins. And these rules where you can specify, well, I want all these types of concepts or these types of concepts, could look something like this. If you have a diagnosis, you want to find all the things in SNOMED that are kinds of diseases. If you have procedures, I want all the things that are kinds of procedures. Even if you are more specific, these are surgical procedures or these are allergies, you can then you don't have to use these high-level hierarchies in SNOMED. You can use more specific, such as subtypes of surgical procedure or allergic condition and so forth. So here I want to show you an example of what I said before, that it's about configuring the system right, because otherwise you may end up in a situation where the clinical users is not selecting the right concepts. And it's not because of the clinical user, it's really about the systems. So if you want to record a new or current diagnosis, in this example, malignant melanoma. So let's say we want to record that this patient has a malignant melanoma. If you perform a search in SNOMED CT, actually this may be a good place for me just to jump to the SNOMED CT browser. Are you able to see this?
Yeah, we can see the browser.
Super. So I go into the browser and I do a search for malignant melanoma. I don't have to type everything. Let me just search for only active concepts. You can see more than 667 matches on malignant melanoma. And then if you take a look here, some of them, we have one of the terms for each concept has these braces where it has a semantic tag stating what hierarchy or sub-hierarchy it's in. And you can see some of these come from disorder, another from a morphologic abnormality, so that's in the body structure hierarchy. There's also a situation. So there are various kinds of concepts, but they all match on malignant melanoma. So let's go back to the presentation here. So the first one that was one of the results is a morphologic abnormality, and that means that's not relevant to a new or current diagnosis, because that represents the morphologic abnormality. so more at a cellular level. So this could be the result of a biopsy. So in the lab, if they have performed or a test of a biopsy, the result could be that that is a malignant melanoma. That is the result, but it's not the diagnosis. History of malignant melanoma refers to a past history of the patient, not a new or current diagnosis. A family history of malignant melanoma refers to some person in the family had malignant melanoma. And these concepts may be relevant in other parts of the system where we want to record the history or where we want to record family history information. But for a new or current diagnosis, a concept such as malignant melanoma, the disorder, would be relevant to capture. So this just shows that you can't just expect a clinical user to use the SNOMED CT browser. We really need to put SNOMED CT into the system and configure it in a way that it can support the accurate use of SNOMED CT and the accurate representation of the information. This is just showing the results of a study that was performed 10 years ago by Dr. Jeremy Rogers in the UK, where they gave clinicians unconstrained access to SNOMED CT for recording the reason for attendance in an emergency department. And as you can see here, in their implementation, it was just a search field. They can just search across everything in SNOMED CT. And what happens then is that the clinicians would use these types of search strings. One would search for temperature, high temperature, drug used, alcohol, lymph nodes. So all of these very relevant search terms, but they would get a very long list of things returned. So without awareness of where the concept sits in SNOMED CT and how SNOMED CT is even designed, it's not possible to select a concept, a proper concept. You can see here that more than 1,000 times the concept temperature was added, but this concept is an attribute, so that means a relationship in SNOMED CT. It's not a clinical concept. High temperature is a physical force. So if something is the force of actually having a high temperature, so that can be used to maybe define the temperature in the air or something. So again, understand why someone may have searched for high temperature, because it's obviously fever that is intended. But because we are not constrained to diagnosis or findings, then we don't get the finding here. The same with alcohol. Well, here we get results where you have recorded alcohol, the substance, and not drunk or alcohol intoxication. That is probably the intention. So this is just to show that you can have a very, very good terminology and a very well and high quality terminology with many good features, but they don't become very good if they are not implemented correctly. So when you choose how you want to use SNOMED, it's important to consider some of these things, that what is the size of the value set that we are using, what is the mechanism that we are using, and what is the preferences by the clinical users. So if you have large value sets, do the search field. Small value sets, you may have a drop-down list, a few options, just use checkboxes. And if you have questions that are mutably exclusive, use question or radio buttons. The point of this is that the same information can essentially be captured in different ways. So you may have a search field to record family history. You may have some text or checkboxes, a clinical free text field with NLP associated, radio buttons. You can have different ways, but the essence is that when you record, you point to the same SNOMED CT concepts, so that regardless of what system you're in or how you have entered this information, it's the same code that is applied. the key principles for doing search is to do a text-based search, and that is constrained to the relevant concepts, as I said, and that you display the preferred term. And the preferred term can be dependent on the country. We have a mechanism for this, so you can define the preference for a whole country. You can define the preference for a local implementation, and then use a word prefix any order search. Where you can search, the order of the terms that you enter doesn't matter, and you just have to enter a few characters, and then the results will start to display. I want to show you an example. This is a demonstration tool that has been developed for the purpose of showing how best practice data entry with SNOMED CT could be done. So it's not a production system, but it's mirroring this. And this up here shows what I spoke about earlier about the architecture, that you can connect to a terminology server. So here we have connected to our Snowstorm. It's actually developed by Kai, and it's the terminology server that SNOMED International uses for our services and products. And this one down here is a terminology server developed by CSIRO. It's called Onto Server. Both of these support the FHIR Terminology Services API, which is an API, a standard API. So this means that the things that you do here, regardless of whether it's in the Snowstorm or Onto Server, because they apply the same FHIR standard and same approach and the same services, then it doesn't matter which one we use. So here we just select the Snowstorm. There is a field here to capture patient details. So you can see there are many fields here, some with the name of the patient, the date of birth. And then we have some with blue fields, and the blue fields indicate that these have been bound to SNOMED. So please notice that it's not because we say that you should use SNOMED for everything. No, you should use SNOMED CT for anything that is interesting to, I would say, like it's something that you would want to share and reuse afterwards, and something that is standardizable. So for the name, we don't have all the names of people in SNOMED. We don't have addresses. That is metadata. So all the clinical context, clinical meanings will be represented by SNOMED CT. In this case, we have a drop-down list of 3 codes here with a smoking status. Up here, we have a list of a few concepts related to gender. And here in the encounter section, you have a field for recording the reason for encounter, diagnosis, procedures, and laterality. And the thing to show you here is that these have been bound to specific hierarchies in SNOMED CT. So we do not search across all SNOMED CT content when we search in these fields. The reason for encounter is a bit broad. So the reason why you come in, if it's an emergency department, it can both be that you have some findings. For example, I was talking about before, the alcohol intoxication. It could also be a procedure. I can't come up with a good example for that. But for example, the event could be that there has been a fall from a ladder or a motor vehicle accident or something. So the reasons why you're coming into this department here can span across multiple hierarchies. But the diagnosis field is more constrained. It's only concepts from the clinical finding hierarchy, and the procedure field is only concepts from the procedure hierarchy. Let us just go down to say that, okay, here I want to say the patient has a pain in the abdomen, and I'll just start to type. And you can see that I get some concepts returned. I'm a bit, I don't really understand why I don't just get pain, abdominal pain. Just do it again. Was there? Let me just try to do a login onto server, and we can see again that it will give me the results. Yeah. And we get different. So it does have an effect regard what order you do it in. Maybe you want to speak a bit to that, Kai. I don't know. Can do that later. But in the diagnosis field, let's say, okay, if I've typed in that the patient had pain in the abdomen, and the diagnosis they end up with is that it's an appendicitis this patient has. I start to type appendicitis. I get the result here, and then here I want to type appendicitis again, and now you'll see I don't get any results because appendicitis is not a clinical finding or a procedure, so this is constrained to procedures. But if I was typing appendectomy, I would get a result because an appendectomy is a procedure. Up here, if I typed appendectomy, I get dehiscence of appendectomy wound, which is a clinical finding. So that's a problem with the wound of the of someone that had an appendectomy. And this is really how you can see that constraining these will make sure that we never end up typing clinical findings in the procedure field and vice versa. Then we have the laterality field, and you can see that's disabled right now. And that's because an appendectomy, if I go to the browser, an appendectomy has a procedure site direct of appendix structure. Remember how Kai showed you in the beginning with the myocardial infarction that you could have defining properties for a concept, and that goes for all concepts in SNOMED CT. We strive to define their meaning through relationships to other concepts. So here we state that for an appendectomy, which is an excision of appendix, we have a method attribute that this is an excision action, and it has a procedure site direct of the appendix structure. So that appendix structure there, that is a primitive concept. We just have an appendix structure with no other defining properties here. One of the properties that we could have is whether or not it was lateralizable, but this isn't lateralizable. We do have a reference set with all the lateralizable body structures. Let's just see if I can find it. Here. So in this subset, we have all the body structures that can have a laterality. For example, the lung. You can have a left and a right lung. We don't have two appendix structures, a left and a right. And the appendix structure itself is not lateralizable. We don't have a right part or a left part. They are not symmetrical in that way. Whereas the nose could have a left side and a right side because the nose is considered lateralizable as a symmetrical body structure. So the appendix structure is not. Let us just look at the nose structure here. Nasal structure. No, I can't see here. Let us do the kidney instead. Here you can see that has a defining property of laterality, to a side, and one of the subtypes here is the left and the right. But overall, it's this indicates that you can have a lateral half and or a lateral, a right side and a left side. So if I go back here and say, okay, appendectomy is defined with a procedure site direct of appendix structure, which isn't lateralizable. What if we said that you had a hip fracture? Or let us take a renal thing, because we just looked at the kidney. Kidney excision, something. Yeah. So now I enter kidney excision, and what you can see is that now the laterality field is enabled, and I can now search for right, left, and right and left. So if I was documenting kidney excision with a laterality of right to indicate what is the kidney that is excised, if I search for kidney excision, it was there. It has a direct side of kidney structure, and kidney structure is part of the, as you can see also here on the ref set tab, of the lateralizable body structure reference set. So this is a way that you can very easily add some logic to your system and support accurate data recording. So those attributes can both be used to state, well, it would be a good idea to indicate what the laterality, you've picked kidney excision, please also add a laterality, but it can also be used to pre-populate. So if we said excision of left kidney down here, look at what happens with our laterality field. It will pre-populate to left, so it will use the defining properties, and then you can't override it, because then you would have some inconsistent and not very useful data if it says excision of left kidney with laterality of right. Okay, so these are just some of the features that SNOMED CT support for data entry. Now I would like to go into a bit of look at how SNOMED CT supports query and analysis. I'm okay with time, and aren't I, Kai?
Yeah, I think we've got another half an hour planned for this presentation. No, not quite that long, 20 minutes.
Good. And then we have a break? Or
we could have a
directly
short break, or you could dive into
into
the next one. It's up to you.
Good. Good. All right. It's just let me know then. Yeah. Good. So when you start to query over patient data, you will have some kind of question that you want your data to help you respond. And one question could be, what is the diagnosis of this patient? And the way that you can get the result for this is to ask within your health record data, what are the values of the diagnosis field? So in your data store, there will be some place in the database where all the diagnoses are stored, and you would get those values out. Oh. So you can just rely on understanding where data is put in the database. So this is the attribute that holds all the information. So it really requires you to know the information model that you're using. I'll keep doing this. Okay, so here's another question. This person wants to know, does the patient have a kind of infectious disease? Again, another question could be, have any procedures been performed on the cardiovascular system? So these are a bit more specific, these questions, compared to the one before. So where we just wanted to look for all diseases, now we want a specific type of disease or a specific procedure on a certain body system. And you can say, well, who wants to do that? Well, it could be for research, but it could also be if you have like an overview diagram or some dashboard for your patient information for in a specific department to display all the things that is relevant here. So these are the types of places where questions like this could be the underlying these underlying questions that result in what is it we want to have queried. So If we want to answer, does the patient have a kind of infectious disease, we can do as we did before, just look up the values of the diagnoses field, and then we'll get all the diagnoses out. So now our task is then to find out, okay, from all of these diagnoses, which one are the infectious disorders? And we can't do that on just understanding where they were stored. We need something else to help us identify the infectious disorders. And the same for procedures. We would go into the procedure field. We will get all the different procedures, but then we will need to know which one of these procedures are actually cardiovascular procedures. So these types of questions require you to use a terminology to find out those concepts that we have stored, which one represents cardiovascular procedures, so that you end up with all the cardiovascular procedures of SNOMED, and then you can compare those to all the procedures that have been recorded and check, is there a match between them? And if there is, then those are the cardiovascular procedures. So this is really where the intelligence lies. The fact that we have a terminology with the hierarchies, with the defining properties and so forth, that what allows us to do some more sophisticated analytics with our data. We do that using the expression constraint language, and I'll show you that in a few moments. This is just showing you why this is super important. So we are recording information about patients. So we store an immense amount of clinical data all around the world. Just think about all the clinical data that is captured in records every minute of every day, just in France even, right? That data can be a valuable resource for when we want to do research and analytics, produce new clinical knowledge that can help us to create some knowledge resources. So that could be everything from a scientific paper documenting new evidence that can be taught to clinicians so that they know these are the latest findings. It can also be new rules and decision support features that can be embedded directly into the clinical record and then fed back to the clinician when they use the system. Regardless of what, the clinical data is driving the creation of new knowledge that can aid the clinicians, and it essentially help the patients. It will help you, it will help me in actually gaining the most out of the healthcare system and the healthcare sector. So it's worthwhile considering how is it we do this most effectively. Take it again. So let me just show you the principles. So here's the concept, pneumonia. That is part of the hierarchy in SNOMED. It sits under a pretty high level concept called disease. And it has a range of intermediate concepts. I just show some of the main ones here, but there are many others. Other concepts such as colitis, appendicitis, bronchitis also belongs to the disease subhierarchy and have a range of other parents or supertypes. And this also just shows that we are only looking at one very simplified branch of SNOMED CT, but you can also already get the idea that it is really a network of things. But this is a very efficient if we want to start answering questions on our data. For example, give me anything that is an inflammatory disorder. Well, you can see here that those 4 concepts that I've selected, they are actually all part of the subhierarchy inflammatory disorder, meaning that these all represent kinds of inflammatory diseases. So that's the common denominator for these 4, is that they are all inflammatory disorders. So if we have patients that have been recorded with these diagnoses, so in their health record, some of them have bronchitis, others have appendicitis and so forth, we can say, well, give me any, if I want to ask something else, well, who of those have a respiratory disease? Well, then we would find not the inflammatory disorder, but the respiratory disease disorder, we can use the hierarchies to identify all the respiratory diseases, and eventually we can match on those patients that have been diagnosed with these concepts. It can also help us to answer a question. I have this patient here. Does this patient have a lung disorder? Okay, lung disorder sits here in the hierarchy. Give me all the supertypes. Maybe that could be an approach. Supertypes of the concept that this patient has been diagnosed with, and check if that matches the lung disorder. Well, it doesn't, so no. From the record, from the diagnosis we've captured, it isn't a lung disorder. So those examples show how we use the hierarchy of SNOMED CT. This example here will show you how we use the defining properties of all the concepts or the attribute relationships. So here you have 8 concepts in SNOMED, and they all have a finding site relationship. Remember how I showed you the appendectomy had a procedure site? Well, anything that is a finding can have a finding site. For example, colitis and dysplasia of colon, they have a finding site of colon structure. Pneumonia has a finding site of lung, as do fibrosis of lung. The concepts can also be defined with a morphology relationship. So please notice how the relationship types has semantics in them. We call them semantic relationships because the finding site is used to identify the location of a disorder. The morphology will talk about what is the morphologic abnormality of this condition. And here you can see the top 4 here has an inflammatory morphology. So that's also why they would also be subtypes of inflammatory disorders. Those down here also have associated morphologies. This one has a morphology relationship of the dysplasia, fibrosis, and abscess. So now we want to say, well, give me all the people that have a disorder located in the colon structure. So this gives us an opportunity to go beyond the hierarchies and say, well, now I'm not looking at the hierarchies. I want to say, give me any concept that is a type of disease that has a finding site relationship with a target that is a colon structure or any subtype of colon structure. Similarly, give me any conditions or disorders that have an associated morphology of a type fibrosis. So this is just to show you that you can use the defining properties to make very specific queries. Often it will be enough just to use the hierarchies because the underlying logic of SNOMED CT will make sure that to group these concepts into the appropriate sub-hierarchy. That's one of the good features of SNOMED is that we are based on a description logic foundation, so that we can have the computers infer the concept's right place in the hierarchy. So the process for doing data analytics with SNOMED is first of all to know what is it you want to ask, what are the patients you want to identify. And from that overall questions, you then can ask, okay, if I am asking this question, what are the concepts in SNOMED CT that I need to identify? So for people with a respiratory disease, then I need to find all the concepts in SNOMED that represent some kind of respiratory disease. And from understanding what concepts you want, you can then start to construct the proper query. And the query is constructed using the expression constraint language. Some of you may be familiar with SQL or other, it depends on the database structure, but the expression constraint language is a query language designed specifically for SNOMED CT, making it easy to retrieve exactly the concepts you want from SNOMED. It has a range of features, this query language. One point I want to make here, because the overall objective today is to talk about implementations. You can see multiple types of people would be involved in implementations. Just looking at this, clinicians, data analysts and so forth would specify these are the questions we need. Someone with terminology insights would be able to then say, well, then we need a query that match these concepts in SNOMED. And then you need someone with some informaticians, some trained in expression constraints to be able to construct it, and also understanding how to execute and apply that on a terminology server. I want to show you an example of data analytics. Tomorrow there will be a more in-depth walkthrough of these data analytics examples. But just one case here is to show how analytics can be useful for clinical care and treatment, for example, to assess how effective a treatment option is. This example is around this scenario here, where some people may have been identified with a mutation of the BRCA1 gene or the BRCA1 gene, and this is a gene that acts. We have it, all of us have it, and it supports the creation of a protein that acts as a tumor suppressor. So those people who have a mutation of the BRCA1 gene has an increased risk of getting cancers, especially breast cancers. So females that have the BRCA1 gene mutation have an increased risk of breast cancer. So there are different ways that you can prevent breast cancer. Is to take some drugs to prevent, and there's a range of drugs available, and some standard products and substances that are used in these products that are used. But the problem is that you may come in feeling completely well and not sick at all, and you don't have cancer. You find out that you have a mutation of a gene that gives you a risk of cancer. But right now you're feeling well and you don't have cancer. And you are then told that if you start to take these medications, you will have a risk of severe side effects. Many people will get hot flashes, nausea, fatigue, the bones will hurt. There are many different side effects of starting to take some medication. And when you are presented with these risks, you really, really would like to have an idea about, well, if I'm going to do this and it's going to affect my the way of living, will it really reduce my risk of cancer? So the way that we can start to investigate this is to do some analytics on our data. First, identify patients with a BRCA1 gene mutation, then separate them into two groups, those who have decided to take cancer preventative medicine, those who have decided not to do it. And then in those groups, then figure out how many was diagnosed with breast cancer. So in order to answer these types of questions, you need to first identify people with a BRCA1 gene mutation, find out the patients who are taking the medicine, and identifying patients then with breast cancer. So these are the questions. Mapping that to the concepts in SNOMED we want to find all the concepts that are types of BRCA1 gene mutation. And this one with the cancer preventative medicine is of course evolving. But we have looked at the NHS recommendations for this, and they have said that tamoxifen containing products, anastrozole containing products, and raloxifene containing products are products that are used for this group. And then people with breast cancer, well, then we want to find all the concepts that represent a disease with the morphology of malignant tumor of breast. So here, the queries, when we transfer that to ECL, descendants of this concept, descendants of tamoxifen or anastrozole or raloxifene containing products, and for the last one, descendants of malignant tumor of breast. So that is the foundation for actually being able to identify. So I just want to show the principles here. So if we have descendants of malignant tumor of breast, that will end up, and we have some patient in our health record that have been diagnosed with these. These are the concepts that have been recorded and the term. So when we execute against our terminology server, all the descendants of malignant tumor of breast, we get a long list of concepts matching this query. And then the objective is then to say, well, any of the codes we have here, is there a match against them with the things we have in our electronic health record? And then we'll see, yeah, we get this one, and these two. So that's the principle. That's what's going on in this data analytics demonstrator. I'm just going to go in to this demonstration tool that has also been created to demonstrate and to actually do data analytics on data, and it actually does work, the system, on patient data, and we can run a session if you're interested in learning how to set it up and how to start using it. But there are three different types of studies you can do here. One is in comparing treatment options, and that's the one that we are going to use here to find out how does patients that are taking these medications, have they really reduced their risk of breast cancer. Before going in here, I just want to show you subsets. We have created this subset of cancer preventative medication. So instead
Anna,
of, yeah.
Hey, could you increase the size a little bit, please?
Of course.
Quite small here.
Good that you say it. Is this better?
That's great. Thank you. Yeah.
Super.
Great.
Good. So here under our subset, we have defined the query that I showed you before: descendants of products containing tamoxifen, descendants of products containing anastrozole, descendants of product containing raloxifene. And we have actually done this using an ECL builder, so you don't have to know the proper syntax and everything. That is constructed for you. So down here we have the ECL, and we have called it the subset breast cancer prevention medicine. You will learn more about subsets later today. Just wanted to show you that we have defined this. So now let's go into the treatments. In this demonstration tool here, we have a few different patient data sets. And the one I'm using here is the main hospital synthetic data set, which includes more than 1.2 million patients. If we want to look for females, we can see that we have more than 600,000 females. We want to constrain these females to only those that have a BRCA1 gene mutation detected. So notice how I just started typing and it will show me matches against BRCA1. And I'll select this one. So now we have almost 1,200 females in our cohort here with the BRCA1 who have been detected with the mutation of the BRCA1 gene. You can see how when I selected this concept, the ECL was added. So treatments, now we want to add a requirement of, you can either, it could be another case where we want to say those who were giving this specific procedure, but in this case we want to say, well, those who were treated with this product. And instead of now, if I just search for tamoxifen, you could see that I would get all the clinical products. Here I get tamoxifen containing products, that's like the overall, and I could also have said something specific. But now I want the subset, so the breast cancer. And now you can see I get the subset. It has these braces with subset, and I'll pick that. And you can see the ECL that we constructed is the one that is connected to that field. Prevention. I'll just name this requirement. And then the outcomes that we're looking at, and I want to include a group for all other patients, so those who didn't get cancer preventive medication. And then I add an outcome. We want those with a breast cancer. Can I just do a search for that? Malignant tumor of breast. And then I run the report. And then you can see those who are taking cancer preventative medicine have just above 30% of those, that group will at some point, or did at some point afterwards, get breast cancer. But the other patients, so all of them who didn't take any of these treatment options, so the cancer preventative medicine, more than 73% of those got breast cancer. So this is so a clinician in the daily work would not go into a system like this. This is of course part of like identifying the correlations between treatments and findings. It can even be like to initiate a clinical study. We need to look into this. Is there really this correlation indicates that there is that it is a good idea, but you would have of course to rely on the published studies and the evidence. So we're not saying that you can just have a system like this and then you will have the evidence. Of course not. It needs to be part of an ecosystem of creating new clinical knowledge. But you can even, if you are in a hospital and you are doing clinical audits, so how many patients in our hospital with this disorder eventually got some infection, or these patients who were giving this treatment, how long time did it go before they were discharged? There can be many types of questions where SNOMED CT can act, and a tool like this can have day-to-day usage.
And I just wanted to emphasize that this tool was for demonstration using synthetic data. SNOMED International doesn't have access to any healthcare records. So this is a demonstration of a tool that could run in your hospital or your group of hospitals.
Correct. Yeah, those two data sets we had there, it is fictional example data. And SNOMED International as an organization, we don't own any patient data. Yeah. I've come to the end of this SNOMED in the EHR presentation. Do we have any questions?